Hi everyone, is it possible that we calculate the length of this line BE from what we have here without the help of any calculator? Okay, let's see. This here is a circle. We can see this angle CBD has its size to be x. The same is for this angle DBE. Its size is also x. That means the two angles are congruent. If you look here, this line AB and this line DF are parallel, and also this line AF and this line BD are parallel. We have the length of this side to be 8 meters. The length of this side AB is A, while this little segment, let's label this point P and call it DP. It has its length to be B, and here we have two equations, 2A plus 4B equal to 20 and 7A minus 3B equal to 36. So how can we solve this? If you look at this quadrilateral ABDF, the fact that this side is parallel with this side and this is also parallel with this tells us that it is a rectangle. Now we know opposite sides of a rectangle are equal. That is, this side and this side are equal, and similarly this side and this side are also equal. But before that, we need the values of this A and this B. Here we have 2A plus 4B equal to 20 and 7A minus 3B equal to 36. We have to solve these equations simultaneously. We can either solve by elimination, substitution, or by matrix. I think elimination will be faster. To solve these two equations simultaneously by elimination, we have to choose the variable which we want to eliminate between A and B. I think we should eliminate B. And in this equation, the coefficient of B is 4, while here it is 3. To eliminate B, we have to make B have the same coefficient in both equations. That is, by multiplying this equation by the coefficient of B here and this by the coefficient of B here. Now multiplying this equation by 3, it will be 2A times 3 plus 4B times 3 equal to 20 times 3, which is 6A plus 12B equal to 60. And this multiplied by 4 will be 28A minus 12B equal to 144. Now add both equations. 6A plus 28A is 34A, plus 12B minus 12B is 0, and 60 plus 144 is 204. So 34A equal to 204. Divide both sides by 34. Here 34 cancels 34, while here 204 divided by 34. Since 204 is the same as 2 times 102, and 34 is 2 times 17, this 2 cancels this 2. 102 is 2 times 51. This 51 divided by this 17 is 3. 2 times 3 is 6. So A equal to 6. That is, the length of this side is 6 meters. Now substitute A equal to 6 into this equation here. 6 times 6 plus 12B equal to 60. 6 times 6 is 36. Take 36 to the right. So 12B equal to 60 minus 36, which is 24. So 12B equal to 24. This 24 is 12 times 2. This 12 here cancels this 12. So B equal to 2. That is, the length of this line DP is 2 meters. Now look at this triangle ABF. We know this angle here is a right angle because it is an angle of a rectangle. Therefore, triangle ABF is a right angle triangle. So if you use the Pythagorean theorem, it states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. Let's assume it to be m. So using the Pythagorean theorem, the square of this m is equal to the sum of the squares of this 6 and that of this 8. So m squared equal to 6 squared plus 8 squared. 6 squared is 36 and 8 squared is 64. 36 plus 64 is 100. So m squared equal to 100. Take the square root of both sides. Here square root of m squared is m, while here square root of 100 is 10. So m equal to 10. That is, the length of this side is 10 meters. Now still on this triangle, if we assume the size of this angle to be y, use the SOHCAHTOA, let y be theta. This must be the opposite, this is the adjacent, and this is the hypotenuse. So theta equal to y, opposite equal to 6 meters, adjacent equal to 8 meters, and hypotenuse equal to 10 meters. Now from here, sin theta equal to opposite over hypotenuse, and here cos theta equal to adjacent over hypotenuse. Theta is y, opposite is 6, adjacent is 8, and hypotenuse is 10. So sin y equal to 6 over 10 and cos y equal to 8 over 10. Here 6 is the same as 3 times 2 and 10 is 5 times 2. This 2 cancels this 2. So sin y equal to 3 over 5, and here 8 is the same as 4 times 2, while 10 is 5 times 2. This 2 cancels this 2. So cos y equal to 4 over 5. We keep that aside for now. Now if you look at this angle y, it is subtended by this arc AB, and we can see this angle ACB is also subtended by arc AB. We know the angle subtended by an arc to any point on the circumference is the same. That is, this angle and this angle are congruent. So since this is y, this must also be y. Now back to this rectangle ABDF, we confirm that this side and this side are equal in length. So since this is 8 meters, this must also be 8 meters. But we have this segment DP to be 2 meters. Therefore, this part must be 8 meters minus 2 meters, which is 6 meters. Now look at this triangle ABP. We know this angle here is a right angle. That is, triangle ABP is a right angle triangle. We can see this side AB and this side BP has their length to be 6 meters each. That is, they are congruent. Therefore, triangle ABP is an isosceles right angle triangle. The angles of an isosceles right angle triangle we know are 90 degrees, 45 degrees, and 45 degrees. So since this is 90 degrees, this angle and this must be 45 degrees each. Now look at this angle and this angle. They are both formed by two intersecting straight lines, line AC and line BD. That means they are vertically opposite angles. Vertically opposite angles are equal. That is, the two angles are equal. So since this is 45 degrees, this must also be 45 degrees. The next thing we are going to do, we come here, draw a chord that connects this point C and this D. Now look at this angle BDC and this angle BAC. Both are subtended by this arc BC. We know the angle subtended by an arc to the circumference at all points is the same. Therefore, this angle and this angle are equal. So since this is 45 degrees, this must also be 45 degrees. Now from this triangle CDP, we know the summation of angles in a triangle is 180 degrees. So since this is 45 degrees and this is 45 degrees, this must be 180 degrees minus 45 degrees minus 45 degrees. 180 degrees minus 45 degrees minus 45 degrees is 90 degrees. That means the triangle is a right angle triangle. The fact that this angle and this angle are congruent tells us that the triangle is an isosceles right angle triangle. And this side facing the congruent angles are equal in length. Let's assume their lengths to be n. Now if you use the Pythagorean theorem, we know the square of this hypotenuse, which is 2, must be equal to the sum of the squares of this n and this n. So 2 squared equal to n squared plus n squared. 2 squared is 4. N squared plus n squared is 2n squared. So 4 equal to 2n squared. Divide both sides by 2. Here 2 cancels 2. While here 4 divided by 2 is 2. So 2 equal to n squared. That is n squared equal to 2. Take the square root of both sides. Here square root of n squared is n. So n equal to root 2. That is, the length of these sides are root 2 meters each. Now look at this triangle BCD. We have the size of this angle to be x. This angle is 45 degrees, while this is y plus 90 degrees. There are some we know will be equal to 180 degrees. So x plus 45 degrees plus y plus 90 degrees equal to 180 degrees. Here 45 degrees plus 90 degrees is 135 degrees. Take 135 degrees to the right and also take y to the right. So x equal to 180 degrees minus 135 degrees minus y. 180 degrees minus 135 degrees is 45 degrees. So x equal to 45 degrees minus y. We keep it aside. Now we know this whole angle AFD is a right angle because it is an angle of this rectangle. So since this part is y, this must be 90 degrees minus y. We come here, draw a chord that connects this point D and this point E. Now look at this angle BED and this angle BFD. Both are subtended by this arc BD. That is, they are equal. So since this is 90 degrees minus y, this must also be 90 degrees minus y. Now look at this triangle BDF. Assume the size of this angle to be z. Based on the rule that the summation of angles in a triangle is 180 degrees, if we sum up this z, this 90 degrees minus y, and this x, they'll be equal to 180 degrees. So x plus z plus 90 degrees minus y equal to 180 degrees. Take x 90 degrees and minus y to the right. So z equal to 180 degrees minus 90 degrees minus x plus y. 180 degrees minus 90 degrees is 90 degrees. This x, if you recall here, we have its value to be 45 degrees minus y. Substitute here. Minus bracket 45 degrees minus y is minus 45 degrees plus y. 90 degrees minus 45 degrees is 45 degrees. Y plus y is 2y. So z equal to 45 degrees plus 2y. We take the cosine of both sides. So cos z equal to cos 45 degrees plus 2y. Now what is cos 45 degrees plus 2y? From trigonometry, there is an identity that cos A plus B equal to cos A cos B minus sin A sin B. If we let A equal to 45 degrees and B equal to 2y, substitute here cos 45 degrees plus 2y equal to cos 45 degrees cos 2y minus sin 45 degrees sin 2y. 45 degrees is a special angle. Both the sine and cosine ratio are root 2 over 2. That is, this cos 45 degrees and this sine 45 degrees are root 2 over 2 each. Factor it out from here. So cos 45 degrees plus 2y equal to root 2 over 2 open bracket cos 2y minus sine 2y. That is, this cos 45 degrees plus 2y is root 2 over 2 open bracket cos 2y minus sine 2y. Now if we take this cos 2y, once again from trigonometry, there is a double angle identity that cos 2a is cos squared a minus sine squared a. Let a equal to y. Substitute here now. Cos 2y equal to cos squared y minus sine squared y. Recall here, we calculated cos y equal to 4 over 5 and sine y equal to 3 over 5. Substitute here, cos 2y equal to 4 over 5 all squared minus 3 over 5 all squared. 4 over 5 all squared is 16 over 25 and 3 over 5 all squared is 9 over 25. 6 over 25 minus 9 over 25 is 7 over 25. So cos 2y equal to 7 over 25. We replace this cos 2y with 7 over 25. Now take this sine 2y. From the double angle identity, sine 2a equal to 2 sine a cos a. Let a equal to y. So sine 2y equal to 2 sine y cos y. Substitute these values of sine y and cos y here. So sine 2y equal to 2 times 3 over 5 times 4 over 5. 3 over 5 times 4 over 5 is 12 over 25. 2 times 12 over 25 is 24 over 25. So sine 2y equal to 24 over 25. Substitute here. Now cos z equal to root 2 over 2 open bracket 7 over 25 minus 24 over 25. 7 over 25 minus 24 over 25 is minus 17 over 25. So cos z equal to root 2 over 2 open bracket minus 17 over 25. Keep it aside for now. Look at this chord DE and this chord CD. They both subtend an angle x to the circumference. In a circle, any two chords that subtend the same angle in the bigger segment are equal in length. That is, this chord and this are equal. So since this is root 2 meters, this must also be root 2 meters. Now from this triangle, we can use the cosine rule to find the length of this side, let's say s. By the cosine rule, the square of this s must be equal to the square of this root 2 meters plus the square of this 8 meters minus 2 times this root 2 meters times this 8 meters times the cosine of this angle. So s squared equal to root 2 meters all squared plus 8 meters all squared minus 2 times root 2 meters times 8 meters times cos z. Recall, cos z here is root 2 over 2 open bracket minus 17 over 25. Substitute here. This 2 cancels this 2. This root 2 meters times this root 2 is 2 meters. 2 meters times 8 meters is 16 meters squared. 16 meters squared times this minus 17 is minus 272 meters squared. This minus times this minus is plus. This root 2 meters all squared is 2 meters squared. 8 meters squared is 64 meters squared. 2 meters squared plus 64 meters squared is 66 meters squared. Now 66 meters squared plus 272 meters squared over 25, simplifying into a single fraction, is 66 meters squared times 25 plus 272 meters squared all over 25. 62 meters squared times 25 is 1650 meters squared. 1650 meters squared plus 272 meters squared is 1922 meters squared. So s squared equal to 1922 meters squared over 25. Take the square root of both sides. Here square root of s squared is s. while here square root of 1922 meters squared over 25 is square root of 1922 meters squared over square root of 25. Square root of 25 is 5. Square root of 1922 meters squared. Since 1922 meters squared is 961 meters squared times 2, square root of 961 meters squared times 2 is square root of 961 meters squared times root 2. Square root of 961 meters squared is 31 meters. 31 meters times root 2 is 31 root 2 meters. So S equal to 31 root 2 meters over 5. That is, the length of this line BE, which we are asked to calculate, is 31 root 2 meters over 5. You can see how we calculated it without the use of a calculator. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.